Hey there, ladies and gentlemen. Today we're going to be solving equations with fractions and decimals in them. Remember, there are shortcuts to do this. You can also do them longhand. Some of you, let's look at our first example. Some of you, know that it's important to get the x terms together and the constants together, but sometimes there are easier ways to go about doing this, which means we can actually, I'm going to go ahead and show you the easy ways or the shortcuts right now. So what we want to do is find a common denominator. So I'm going to write that up here, or let's say least common denominator. Hopefully you know what that stands for. But once we find that least common denominator, you should be able to multiply the entire expression by that least common denominator. I see I have 3, 5, and 15. Because 3 and 5 are factors of 15, I'm going to multiply the whole thing times 15. Now, it's not 15 as a fraction, it's, 15 over 1. So when I go through and multiply, my first term will be 15x over 3. My second term will be 45 over 5. My third term will be negative 15 over 15. And then I have 15x over 15. So the good thing in here is that we can simplify now all of our fractions. If I have 15 over 3, that becomes 5x. 45 over 5 would be 9. 15 over 15, and it's negative, so that's a negative 1. Plus 15 over 15, so that would be just x, or 1x. Remember, we don't have to put the 1, it's imaginary. So now look, we have a nice, pretty problem here. Now we can start combining our like terms by moving them from one side to the next. I'm going to get rid of the negative, so I'm going to add 1 on both sides. So I have 10 over here. So I have 5x equals x, because these cancel. Now I'm going to go ahead and subtract 5x. I guess that negative was inevitable. So 10 equals negative 4x. Okay, now of course looks like we're going to end up with a fraction as a solution, which is okay. So I have 10 over negative 4. They're both divisible by 2, so that gives me 5 over 2, but it's still negative. It's improper, so 2 goes into 5 2 times, so this would be 2 and a half, and of course it is negative, so this would be our final solution here. All right, let's try another. I'm going to erase some of this. So I have space. All right. So for our next one, I have denominators of 3, 2, and 4. So this one's a little bit trickier because 3 is not a factor of 4, 2 is, but 3 isn't. So when I look at this, what number is the smallest number that 3, 2, and 4 are all factors of? And I actually believe it is 12. So that's our least common multiple here. So that means I'm going to multiply the entire thing times 12 over 1. So when I do this, I end up with 12x over 3 minus 12 over 2 equals 36 over 4. So now I can go back and simplify all of my fractions. So when I do that, 12 divided by 3 is 4, so that would give us 4x. 12 divided by 2 is 6. 36 divided by 4 is 9. Look at that. A lot neater than having to deal with all those fractions. So now I'm going to add 6 on both sides. So I have 4x equals 15. I divide by 4. So unfortunately, I end up with, again, a mixed number. So 4 goes into 15 3 times. 3 times 4 is 12, which means I'm left with 3/4. So this would be our final solution. All right, ladies and gentlemen, we're going to continue with solving an equation that contains decimals. So here we says it costs $50 to rent a booth at the carnival. Each bag of cotton candy costs 20 cents to make. I'm going to make a note right here that 20 cents is this. You sell a bag for $1. How many bags of cotton candy do you need to sell to break even? Remember, breaking even is revenue and costs are the same. So let's see. It costs $50 to rent a booth, so 50 is part of our cost. Each bag costs 20 cents to make, so we're looking at each bag being 20 cents a bag. So X is going to be bags. Fair enough? And it says you sell the bag for $1 a piece. So here's our dollar and X. So in order to set up this equation, we would have 50 plus 20 cents X equals $1 X. All right, now the decimals here are actually pretty simple, but what we can do to help ourselves when they kind of get a little crazy is we can actually multiply the entire expression by a base 10 that would eliminate those decimals. So in this case, I can actually multiply the entire thing times 100. Because of these two zeros, it'll eliminate the two decimal places that we're looking at. So if I have a 50 times 100, that would give us 5,000. Of course, right now it's not realistic. Plus 20x. And then here, this would be 100x. The next thing I can do is start solving for the variables by combining my like terms. So this would be gone, and here I'm left with 80x on this side. And then I have 5,000 on this side. So when I solve, x equals 62.5, but we can't sell half a bag, so this is not really a realistic answer, but at least it'll give us an idea whereabout we would be breaking even as far as the cotton candy sales are concerned. Let's try another one. This one is very similar, so we're going to start by finding our base 10. I have two decimal places, so that means I can multiply each one by 100. Remember, you can't multiply one side and not the other. You must multiply the entire expression by 100. So here we would have 400n plus 24 equals 1,576. I know those are kind of crazy numbers, but it'll be okay. So continuing on, I'm going to move my constant over here. So now I have 400n equals, let's see, 1576 minus 24 will give us 1,552. I'm going to divide by 400, divide by 400. Now I can tell you that this is not going to be a very user-friendly decimal, but we know we're going to end up with a decimal because we had decimals pretty much at the beginning. So this will be 3.88. So n equals 3.88. And of course, we can check that by substituting back in to our equation. Remember, you can use Desmos to help you through this process.